Hello friends, welcome to Insight Learners. Today we shall discuss the next problem using the limits of the form infinity minus infinity. Evaluate limit as x tends to 0, 1 divided by x minus 1 divided by e raised to x minus 1. So first we shall write the given. So the given is limit as x tends to 0, 1 divided by x minus 1 divided by e raised to x minus 1. So we shall check the form by substituting the limit as x tends to 0. So as we know that 1 divided by 0 is nothing but infinity. So therefore 1 divided by 0 is infinity minus 1 divided by e raised to 0. So e raised to 0 is nothing but anything raised to 0 is 1. So 1 minus 1 will be 0. So again 1 divided by 0 is infinity. So therefore we can see that it is of the form infinity by infinity form. So whenever there is a infinity by infinity form, our first step is to take the LCM on both the sides. So first step is to take LCM on both sides. So to take LCM on both sides. So then afterwards, once the LCM is taken, so next step is we need to convert it into either 0 by 0 form or infinity by infinity form, and then we need to directly apply the L'Hospital's rule and obtain the constant value. So after that we need to convert it into, convert into 0 by 0 or infinity by infinity form and then apply L'Hospital's rule. So this is the same step for all the problems of the form infinity minus infinity form. So then first step is we need to take the LCM on both the sides. So the given f of x equal to 1 divided by x minus 1 divided by e raised to x minus 1. So first step is we need to take the LCM on both the sides. So here the total LCM of x into e raised to x minus 1. So the LCM will be e raised to x into e raised to x minus 1. So here you can check there is 1, here also 1. So at the denominator we have x, but we do not have e raised to x minus 1. So multiply it with e raised to x minus 1. Similarly here at the denominator we have e raised to x minus 1, but there is no x. So multiply it with x so that we obtain this LCM. So 1 into e raised to x minus 1 will be e raised to x minus 1. Then minus 1 into x is nothing but again x. So now we have find the LCM of on both the sides. So next we shall again substitute the limit as x tends to 0 and check the form whether we have reduced it to 0 by 0 form or infinity by infinity form. So then we need to substitute the limit as x tends to 0. E raised to 0 is 1 minus 1 is 0 minus x is 0. So by substituting the limit as x tends to 0, so limit as x tends to 0, e raised to x minus 1 minus x whole divided by x into e raised to x minus 1. So e raised to 0 minus 1. So 1 minus 1 is 0 minus 0 divided by 0 into entire term will be 0. So therefore we have reduced it to 0 by 0 form. 0 by 0 form. So once we have reduced it to 0 by 0 form, now we need to apply the L'Hospital's rule. So using L'Hospital's rule, we need to differentiate both numerator and denominator. So using L'Hospital's rule, differentiating numerator and denominator. So differentiating numerator and denominator. Differentiating the numerator and denominator, so we have the equation. So that is the given f of x. So f of x equal to, so whatever we have obtained after applying the LCM. So e raised to x minus 1 minus x whole divided by x into e raised to x minus 1. So we need to apply the L'Hospital's rule and differentiate the numerator and denominator. So differentiation of f of x is f dash of x equal to. So then we shall differentiate both numerator and denominator. So differentiation of e raised to x is nothing but e raised to x as it is minus differentiation of 1, that is a constant term, will be 0. minus differentiation of x is 1, then whole divided by, so differentiation, so we shall apply the u into v rule. So that is x into e raised to x minus 1. So differentiation of, so we need to apply the u into v rule. So that is x into e raised to x minus 1. So that is keeping x as it is and differentiation of e raised to x minus 1. So first differentiation of x is 1 into, so keeping e raised to x minus 1 as it is, then plus, so keeping x as it is into differentiation of e raised to x is e raised to x minus differentiation of constant term 1 is 0. So that is f dash of x equal to e raised to x, so minus 0, so minus 1, keeping minus 1 as it is. So then whole divided by, so this will be 1 into e raised to x minus 1, so e raised to x minus 1 plus x into e raised to x. So again now we have not obtained any constant value, so again we shall differentiate this. So again differentiation of f dash of x will be f double dash of x equal to, so e raised to x is e raised to x minus differentiation of constant term is 0, then whole divided by, then e raised to x minus 1, so differentiation of e raised to x is e raised to x minus 1 is 0, plus again apply u into v rule for this. So it will be 1 into e raised to x plus x into e raised to x. So therefore we shall write the f double dash of x equal to e raised to x whole divided by e raised to x plus e raised to x plus x into e raised to x. So now we shall directly apply the limit as x tends to 0. So limit as x tends to 0, e raised to x whole divided by e raised to x plus e raised to x plus x into e raised to x. So e raised to x, so differentiation, so substituting the limit as x tends to 0, e raised to 0 is 1. So 1 divided by e raised to x, again it is 1 plus this x, 0 into entire term will be 0. So this will be 1 divided by 2. So 1 divided by 2 is the required result for the given equation. Thank you friends. For more problems on L Hospital's rule, go to our channel and please subscribe us.